Hello everyone, welcome second year students, English section, Faculty of Commerce, Sadat City University. This is Reem Subhi. I will be with you in sections of Mathematics of Finance, Part 2 Compound Interest. I'm a teaching assistant at Insurance, Mathematics and Statistics Department. In this section, we will discuss Chapter 6 titled Deferred Annuities. Let's start with the definition of deferred annuities. What do we mean by deferred annuities? Deferred annuity is a series of equal payments made at the beginning or at the end of each period, either annually, semi-annually, monthly, weekly, daily, and so on, but after a deferred period. So, the deferred annuities are a series of equal payments made after a deferment period, and it may be at the beginning or at the end of each period. So the deferred annuity affects only the present value of annuities. The present value of an ordinary annuities, we have two types of annuities, deferred and annuity due. So we in this chapter we want to know the present value of the ordinary deferred annuity, and this is using the formula an deferred equals r times 1 minus 1 plus I to the power minus n over I times 1 plus I to the power minus f. This is the present value of an ordinary deferred annuity. The present value of a deferred annuity due is r times 1 minus 1 plus I to the power minus n by I times 1 plus I times 1 plus I power minus f. So what is the difference between minus n and minus f? Minus n is the number of the payments or the equal payments, but f is the deferment, the number of deferment periods. Let's take some examples. A payment of $1,100 is made at the end of each year for 5 years. So we have equal payments equals to $1,500. So this is R. And these payments are made at the end of each year. So if the payment or annuity is paid at the end of the year, so this is an ordinary annuity. And this annuity is made for 5 years. What is the present value of these payments if they deferred for 3 years? So this is the deferment period. And the 5 years are the payment periods. And the interest rate is 9% compounded annually. So this is J, and M equals 1 because it's compounded or converted annually, and N here equals 5 years times M, which is 1, so N equals to 5, and the deferment period equals to 3, so F equals to 3 times M, which is 1 also, so F equals to 3. So from this example, we have here J equals 9 and M equals 1. So I, which is J over M, equals to 9%, and N equals 5, F equals 3. From this example, we previously said that the payment is made at the end of each year. So it's an ordinary annuity, but it's a deferred ordinary annuity. So we would use the formula, which is an deferred equals R times 1 minus 1 plus I to the power of minus N over I times 1 plus I to the power of minus F. This is the formula of the present value of the ordinary annuity. by substituting R with 1,000 and 100 and 500 and I with 9% and N with 5 and F with -3, we get the present value of these payments, which is 4,500.5. Another example, an ordinary annuity of $500 is made at the end of each 6 months for 7 years. So our payment here is R equals to $500 and is made at the end of each 6 months. So M equals to 2, as the payment is made twice a year, every 6 months, and this for 7 years. So N would equals to 7 years times 2, which is M, so N equals to 14. So we will have 14 payments, each one equals to 500. And the bank pays 8%, and this percent converted semi-annually. So this is J, and I equals to J over M, and this equals to 4%. What is the present value of these payments if they deferred for 1 year? So the deferment period is a year, and F equals to 1 times 2, which is M. So the number of a deferment period, which is F, equals to 1, the deferment period 1 year, and the M equals to 2, so F equals to 2. So again, from the example, J equals 8 and M equals 2, so I is 4%, J over M, and N equals to 14, F equals to 2, and R equals to 500. And from this example, he said that an ordinary annuity, and he needs the present value of this annuity as it's deferred for 1 year. So we will use the formula AN deferred equals R times 1 minus 1 plus I to power minus N by I times 1 plus I to power minus F. By substituting the values of R, N, I, and F, we get this shape. So the present value of these annuities is equals to this amount. Another example, find the present value for the payments in the last example or the previous example, but if they are made at the beginning of each 6 months. So we will resolve the example 2 again and find the present value of these payments, but they are made at the beginning, not at the end of each 6 months. And as they are made at the beginning of the period, so it's an annuity due. And M equals to 2. So J again is 8%, M 2, and I is a 4%. So N equals to 14 and F equals to 2, and R also equals to 500. But in this example, the annuity is a deferred annuity due. So the formula will differ in here in this example, and it will take this formula or this shape. AN deferred equals R times 1 minus I plus 1 plus I to the power of minus N by I times 1 plus I. So we added here 1 plus I, and added to multiply this amount or this value in this side times 1 plus I to the power minus F. By substituting the values of R, I, N, and F, we get 500 times 1 minus 1 plus I, which is 4%, the power of minus 14 over I, times 1 plus I times 1 plus I to the power of minus F. So the present value of these annuities due but deferred equals to this amount. Example 4. A man deposits $900 at the end of each month for 2 years in a bank that pays 10% compounded monthly. What is the present value of these payments if they differed for two years and a half? So the man deposits $900, which is R, and this is at the end of each month. So it's a periodic payment. So this is an annuity, and as it made at the end of each month, so this is an ordinary annuity. And this would be made for 2 years. So M here equals to 12 as its monthly payment, and for 2 years, so M equals to 2 times 12, this is equals to 24. So we have a 24 payments, and the bank is paying 10% compounded monthly. So this is J, and I equals J over M. What is the present value of these payments if they differed for 2.5 years? So this is the deferment periods, and F equals to 2.5 times 12, and this equals to 30. So J 10%, M 12, and I equals to J over M, and this equals to this amount, N equals to 24, and F equals to 30. And this annuity is an ordinary annuity, and we need to know the present value of these annuities after a deferment period equals to 2 years and a half. So by using the formula of the present value of a deferred an ordinary annuity, by substituting the values of R, I, N, and F, we get A24 deferred equals to 900 times 1 minus 1 plus I, which is 0.0083 to the power of minus N, and N equals to 24 over I times 1 plus I to the power of F minus F, and F equals to 30. So the present value of these payments equals to this amount. Example 5. Find the present value if the payments are made at the beginning of each month. So in this example, he needs you to resolve the previous example, but supposing that the payments are made at the beginning, not at the end of each month. So you will treat these payments as annuity due. And again, J equals to 10%, M 12I, J over M, and N equals to 24, F equals to 30. So at the beginning of each month means annuity due, and the present value of the annuity due, deferred one, equals to AN deferred R times 1 minus 1 plus I to the power of minus N over I times 1 plus I times 1 plus I to the power of minus F. And by substituting the value of each quantity R, I, and F, we get the present value of these payments. Example 6. A person bought a car from a car dealer for a $2,000 down payment and a $300 for each month for 3 years. What is the cash value of this car if the interest rate is 6% monthly and payments are deferred for 6 months? So in this example, the person bought the car for 2 payments. First one is $2,000, which is a down payment, and the rest of the price of the car would be installed or would be paid in installments or in equal payments, which are $300 for each month for 3 years. So the payments or the annuities would continue for 3 years. So M equals to 3 times 12, as the payments are made for each month. So M equals to 12. And N, 3 times 12. This equals to 36. He needs the cash value, which is the present value also for this car. The cash value of the car equals the price of the car, and this equals to down payment and the present value of the annuities we already have the down payment, which is $2,000, and we need to find the present value of these annuities. And as the annuities or the payments are made at the end of each month, so this is a deferred ordinary annuity. And the interest rate is 6% monthly, so J equals to 6% and I equals to J over M. Payments are deferred for 6 months, so the deferment period is 6 months, and F equals to 6. You are not going to convert these 6 months as it's in months. If it's in years, you will convert this period, but in this example, he's giving you the deferment periods or the number of the deferment periods in months. So it's already converted. Again, J 6%, M equals to 12, I is J over M, 6 over 12, so 6% over 12. And N is 36, which is 3 years times 12, and F equals to 6 months. And the payment, the present value of the ordinary annuities equals to AN deferred equals to R times 1 minus 1 plus I to the power of minus N over I times 1 plus I power minus F. By substituting values of R, N, I, and F, we get the present value of the ordinary deferred ordinary annuities. So the cash value or the price of the car, which is equals to the down payment and the present value of these annuities. The down payment equals to 2,000 and the present value of these annuities. By adding these two amounts, we get the price of the car. So this is the price of the car or the cash value of the car. Example 7. Find the cash value of the car if the payments are made at the beginning of each month. He wants you in this example to resolve or re-answer the example 6 again, but in this example assuming that the payments are made at the beginning of each month, not the end. So these payments are annuity due, not ordinary one. So again, J equals to 6% and 12I 005 and 36, F equals to 6 and R equals to 300. By substituting with these amounts in the formula of deferred annuity due, be careful here, we had another formula which is equals to R 1 minus 1 plus I to the power of minus N over I times 1 plus I times 1 plus I to the power of minus F. So the formula of the annuity due is different from the formula of the ordinary annuity. By substituting the values in this formula, we get the present value of these payments. And the cash value equals the down payment, which is $2,000, and the present value of these deferred annuities, which is equals to this amount. So by adding these quantities, we get the present value of, or the cash value of the car, or the price of the car. Example, given A N deferred and R N M F, find I and J. So in this example, he's giving you already the present value, but for a deferred ordinary annuity. This is the present value of a deferred ordinary annuity. And R is the ordinary annuity. N equals to 20. So we have a 20 deferred annuity, ordinary one. N is 2, so these annuities are paid twice a year. F is 2, so these annuities are deferred for a year. We can draw our example. So this is now 0, and we need the present value of these payments, and these payments are deferred for 2 periods. Each one is 6 months, so this is 1 year, and the rest of payments are made after the deferment period. So this is the deferment period, and this is the period of the payment period of the annuities. And in this example, we need the present value of these payments. We have 20 R or 20 annuities. So by using the formula of the present value of the deferred annuity, ordinary annuity, which is A N deferred equals R times 1 minus 1 plus I to the power of minus N over I times 1 plus I to the power of minus F. We use the formula of the deferred ordinary annuity, as he is giving me in the example the present value of these ordinary annuities, not the due one. By substituting the values or these amounts in the formula, we get, this is the amount of the present the present value of the ordinary annuities, and this is R 200. 1 minus 1 plus I. We don't have I, so we have to find I to the power of N minus 20 over I times 1 plus I to the power of F, which is minus 2. By dividing this side over 200, we get 16.4, and the rest is 1 minus 1 plus I to the power of minus 20 over I times 1 plus I to the power of minus 2. By multiplying this amount times this amount, we get 1 times 1 plus I to the power of minus 2 gives 1 plus I to the power of minus 2, and 1 plus I to the power of minus 20 times 1 plus I to the power of minus 2. The base is the same, so we will add the power. So 1 plus I to the power of minus 22, as 20 plus 2 equals minus 22 over I. By trial and error, by using the trial and error method to expect the periodic rate I, we can say that it may lies between 1% and 2%. So if we assume that the interest rate, the I or the periodic rate equals to 1%. By substituting 1% in this formula, we get this value, and this value is greater than 16.4. So we need to maximize this rate, and we will take a 2%, made I by 2 equals to 2%, and by substituting with the value of 2 in this formula, we get 15.7. so this is less than 16.4. So we have two values here, one greater than 16.4 and one less than 16.4. So we need the I which lies between these two rates, and this by using this formula, 16.4 minus 17 over 15 minus 17, and again 16.4 minus 17.68 equals to I minus 0.1, and this over 15.7 minus 17 over 2% minus 1%, and this equals to this amount, as you can see here, 16.4 minus 17.6 and 15.7 minus 17.6, and this equals to I minus 1% over 2% minus 1%. By finding this value, find this value first, and then time this side by the difference between 2% and 1%, which equals to 1%. Then I would equals to 0.0165. To check the answer, we will substitute the value of I in this formula, as you see here. So 16.4 equals to 1 plus the I that we just found, equal power minus 2 minus 1 plus I power minus 22 over I, and this would equals to 16.37, which equals to 16.4, and I here J equals to I times M, as I equals J over M. So we already have I and we have M. I equals to 0.0165 and M equals to 2. So by multiplying these quantities by each other, we get J, which is 3.3%. Again, another example. Given the present value of a deferred annuity due. So in this example, is giving you the present value, but for a deferred annuity due, and this equals to 750. R equals to 100, and N equals to 10, M equals 4, F equals to 5, and he's asking about I and J. Let's first find I and then find J. By substituting in the formula of the deferred annuity due, which is equals to R times 1 minus I plus I to the power of minus N over I times 1 plus I times 1 plus I to the power of minus F. By substituting the present value of the annuity due, which is 750, and also the value of R equals to 100, and the value of N equals to 10, the value of F equals to 5. Again, dividing 750 over 100 gives 7.5, and the rest we can multiply these sides, we have the same base, so we can add the power, as this 1 plus I is the same as 1 plus I, but we have different powers here. The power of 1 plus I equals to 1, and the power of 1 plus I equals to minus 5. And if we have the same bases, if we have two quantities multiplied with each other with the same base, we add the powers. So 1 minus 5 equals minus 4. So this quantity will turn to 1 plus I power minus 4. By multiplying this quantity by 1, we get 1 plus I to the power of minus 4, and 1 plus I to the power of minus 4 times 1 plus I to the power of minus 10. Again, same base, so we would add the power, so it will be minus 14 over I. By using the trial and error method, we expect the periodic rate I lies between 3 and 4%. So, by assuming I, or the periodic rate equals to 3%, by substituting with I in this formula, we get the value of this quantity, which equals to 7.57, and this is greater than 7.5. We need exactly 7.5, and by substituting I with 4%, we get this amount. So we have I lies between these two amounts, so we would find the difference between the internal amounts, which is 7. These are the internal amounts, 7.5 minus 7.578, and I minus these the internal amounts. And this difference over the external amounts, which are 6.9 minus 7.5 and 4% minus 3%, and we can see this in this relation. So 7.5 minus 7.5789, which are the internal amounts, and this equals to I minus 3. These are the internal over the external amounts. 6.93322 minus 7.57. This equals to 4% minus 3%. First, find the value of these amounts, and then multiply this with the difference between 4% and 3%. Then add 3% to them, and you will get the value of I, which equals to 0.03123. By substituting the value of I in this formula, we get that the same amount, which is 7.495, and this is almost equals to 7.5. So I is equals to 0.03123, and J equals to I times M. So by substituting the value of I and the value of M, which is 4, we get J, and this equals to 12.5%. Example 10, given the present value, this is the present value of a deferred annuity due, as between brackets, this is the abbreviation of deferred, so this is a deferred one, and AN, and you have 2.4 here, so this is the annuity due, not ordinary one. So this is the present value of deferred annuity due, and the formula of the present value of a deferred annuity due equals to r times 1 minus 1 plus I to the power of minus n over I times 1 plus I times 1 plus I to the power of minus f. Again, you can get back to the example and see what do you have and substitute in this formula. We have a n and we have the r, which equals to $800, and we get I, m equals to 12, f equals to 3. So we don't have n, and he's asking about how many full payments are there, so he's asking about n. By substituting an and r times 1 minus 1 plus I to the power of n, and we don't have n, over I, 1 plus I to the power of minus f. So you can multiply 800 times this quantity and this quantity, and then dividing this side over the amount you can get, or over, you can see that 12,750 over times 1 plus 5 times 1 plus 0.005 power minus 3. So this equals to this amount, and the rest is equals to 1 minus 1 plus 0.005 to the power of minus n over I. Again, you can multiply these quantities by each other, and then 1 minus the answer. So the rest you'll have is 1.005 to the power of minus n. We need to know n, or the value of n. So we will take the logarithm of both sides. When you take the log of any side, of any number, that have a power, so this would equals to minus n log 0.5. So by divide, and also log this quantity by dividing both quantities over each other, we get the value of n, which is also by negative sign, so negative goes with negative, so n equals to 16.8. So this means we have 16 full equal payments of $800, and the 17th one would be less than 800. So because we have 16 full payments and a part or a portion of the payment, so we have 16 full equal payments of $800, and the 17th one would be less than the 800. Thank you for watching this video. Hope it's useful to you. See you at the next video, inshallah.